It's a mess in this attic. Lot going on, but there ain't no need to panic.
So your daughter's name is Nova.
Yeah.
That's hilarious. She's gonna be one of those kids. It's like, oh, my dad's always talking about going to space. I just want to do this, be a farmer.
I worry about that sometimes, but she's gonna have to put up with it. I mean, her daycare is on the NASA campus right now, so she's hanging out with a bunch of other NASA babies.
Oh yeah. No offense to your dad, but like he was a boss at GM, and now you're at NASA. So really, it's getting better every generation. So she'll probably be I don't know. She'll probably be running the moon or some shit.
She should be the president of the moon.
The president of the moon. Yeah, it's a big role.
Coming up and join, we getting wild, getting manic, spitting truth for all you fanatics. Every week got something new to say. Ain't no filter, this shit coming straight from the brain. It's coming straight from the brain. Yeah, it's coming straight from the brain.
What's up, everybody? Welcome to our... Get out of here, Newtsy. What's up, everybody? Today is Friday, September 24th. This is A Talk in the Attic, which means, of course, I'm your host, Kirk Ross. If you're watching on YouTube, you'll probably notice that I'm hanging upside down. And if you're wondering why, well, I'll tell you. I just recently learned online. Of course, the internet is one of the most reputable sources of information. I read online that I could hang upside down to achieve a near weightlessness, similar to that of famous astronauts who have come before us, like Matt Damon and Matthew McConaughey. Today's episode is all about space. And according to our friend and today's guest, Kevin Rainbolt, who's a lead software specialist at NASA, an all-around space nerd, and also a good friend of mine, according to Kevin, I actually might have an opportunity within my lifetime, assuming that hanging upside down doesn't kill me first, to actually travel to space. Kevin has always wanted to work for NASA since he was a kid, and last year he achieved that dream, and now he's here today to give us a bunch of knowledge and to shower us with truth and facts, similar to a meteor shower striking the exoplanet of XR37, a star that I just made up. As you can tell, I'm struggling to stay conscious, struggling to stay coherent, so let's just move right on into the show. This is Kevin Rainbolt. It's a good one. Let's start the show.
Well, folks, welcome to Space Talk in the Attic. Sometimes people say, well, it was complicated, but it wasn't exactly rocket science, right? Well, today, unfortunately for me, because I'm going to be the dumbest guy in the conversation, which is going to be humbling. I have Kevin Rainbolt here. He's he's technically a lead software developer at NASA, but let's call it what he is. He's a rocket scientist. He's a personal friend of mine. He's a cool guy. Welcome aboard, Kevin.
Thanks a lot, Kirk. I appreciate you having me.
Yeah. So talk a little bit. So Kevin, who are you? Let's get informal quick. Talk about your personal side a little bit. So establish a foundation if this were a court proceeding as to why you're somebody we should listen to.
Right. So I am super passionate about aerospace, astrophysics, NASA, and I have been since I was probably 13, and I picked up a book called A Brief History of Time by Stephen Hawking. My science teacher gave that to me. Ever since then, I've just sort of been like, NASA is my future. But to get there was a long road. And so, nowadays I do work for NASA and I do software engineering, but up to this point, up to this job, I had done a number of different jobs and related in software.
Yeah. So are you, you went to school for computer science or for actual coding, software development, or what's your background there?
Yeah, that's a great question. So I went to the University of Michigan, actually originally for astrophysics. And I did 2 years in the astrophysics program, was doing research, realized, your job opportunities are limited with an astrophysics degree. You essentially have to go in and become a professor, and you have to get your PhD. And 19-year-old Kevin wasn't quite ready for that type of commitment. But I switched into computer science because a lot of what I was doing in research was coding. And so it felt very natural. And so I switched to computer science in 2 years, got my degree, and then kind of went out into industry. And I've worked on like government financial software, software for manufacturing, RFID scanners. And then I got into a more aerospace software engineering for the last 6 years, and now made my way into NASA.
Yeah, so you were in the private sector, but still an aeronautical here in Grand Rapids for a period of time, right? Then that was before you got into NASA.
That's correct. Yeah. So for a while, I worked in outside of Lansing, which is where I grew up, in something unrelated to aerospace, but software development. Then kind of did some soul searching, decided that as much as I loved working on government financial software, I felt like I needed to make a change. And the best opportunity I had was to find somewhere that would do software engineering in the aerospace industry. So I did move to GE Aviation in Grand Rapids and worked there for 6 years as a lead software engineer, and then got a master's and got certifications and things in project management, just to build up my resume until the time at which I felt prepared to apply to a NASA position.
I could tell you were a PMP just by the way you sent me this outline. I could tell this guy's a professional project manager.
Is it that obvious?
No, that's a good thing. This is I've rarely, folks, do I feel like I'm the disorganized one out of the interview, but today is absolutely the case. But that's because I'm dealing with the PMP. I was just a basic project manager.
My apologies.
So, is it expected when you get a gig in NASA, which is a highly sought after thing? Just because of like, even I really don't even know if that's true, but just it feels like it would be because of the perception of it. Is the expectation that you've had some experience in aerospace when you get a job in that, or what's at least in the technical side?
I don't necessarily think so. And in fact, I think some of my experience prior to working at GE really helped me get in here because it was more focused on some of the development that I'm working on now in web technologies. Yeah. So it's not necessary, but it definitely is competitive. Like in terms of civil servant positions, which are actually, federal government positions, they're fairly uncommon just because there's very little turnover in the federal government, especially at NASA, which is, at least in the most recent survey, like the best place to work in the federal government. So most people are staying there for life once they get their foot in the door. So very few jobs appear. And I had actually been applying for, or at least watching for job opportunities for about 3 years, and applied to a few of them, had some interviews, didn't get in, and then did get offered a position, but it did take 3 years. So perseverance was definitely key, but not everybody needs to have 6 years of aerospace software engineering work before they try to get into NASA. There's many of avenues. And in addition, the federal service is one component of it. In fact, a lot of people that work at NASA are contractors. They're sort of the ones that are actually doing a lot of the work, that are most of the spacecraft that we're building, many of it at least, is built by contractors that the government is contracting out to. So oftentimes it's a little easier to get in with a contractor.
Yeah, and that kind of gets you in the door, at least speaking the right language and kind of seeing how it actually works. Now, when you were at GE, were you involved with NASA at all as a contractor?
Not really. I was doing more like aviation stuff. So I worked a lot in flight simulation software and working on flight management systems like autopilot software for commercial and military aircraft. Mm-hmm. So I did a lot more stuff with like Boeing and Airbus, and some of the military aircraft as well. But I didn't work too much in the NASA stuff, unfortunately.
Well, you're here now.
Yeah,
you're actually
right.
so let's forget about GE for a minute. No disrespect to you, GE, or any of the colleagues that you had there. But let's talk about NASA. Let's talk about what you're actually working on now. Like, what are some projects that you yourself folks, I want to make you understand. Kevin's here as a friend and as absolutely a space nerd, if you will. And he's here representing NASA as well, but he's not speaking on behalf of NASA in all these cases. So he'll make clear when he's talking about something he intimately knows about, and when he's talking about things more as a fan or as a geek. Okay. Is that good, Kevin? Do you agree?
Absolutely. And I'll provide those disclaimers as we go through here. I certainly have been studying astrophysics and what goes on at NASA for long periods of time, but I do have a very niche specialty right now that I'm working in. And so that is, I work essentially under the Office of Safety and Mission Assurance, which was an organization that was stood up after the Challenger accident, when they realized that there wasn't enough technical oversight for safety and mission assurance when we're putting these missions together.
Right.
And so this organization is there to just review all of the technical details of these systems to ensure they're all working within specification, working to these certain sets of requirements to really ensure that the mission has as low of risk as possible, within tolerance.
Yeah. Right.
So the software that I develop is to those ends, essentially, is as a number of different applications that are trying to ensure the safety of the crew and of the materials and of our property and just humans in general, and then ensure mission assurance to make sure they're as successful as possible.
So you're developing, and maybe this is yes in all cases, but are you developing more of the precursor system process based software, or are you actually doing onboard software as well, or is a little of both?
So I'm not doing flight software, which someday maybe I'd like to do that, but there's a lot more red tape that goes along with that. I work in a smaller development group right now, and we do more of like the support ground-based systems, and a lot of which is really focused on safety. So for instance, like tracking certifications and qualifications for the engineers who are building these systems. You need to be trained in how to handle hazardous materials when you're fueling a spacecraft or something.
Right.
And so we need to be able to ensure that those individuals have the training that they need in order to handle that. Some of the other things I'm doing in terms of software development are to improve the process and the workflow of planning for early missions. So early on, when a mission is just a seed of an idea, there's a very small number of people that have been funded to go work on it, but they still need to put together plans on
it's
how
the foundation.
Make this thing happen.
It's the foundation of the whole thing too. Yeah.
Right. Exactly. So any little change early on is going to have a huge impact later on within the mission's implementation.
Right.
And so I'm really I'm working to try to help them use technology and software systems to automate some of those processes that have been very manual, to really like guide these early engineers to making the best decisions possible to really result in a safer, more efficient, more effective mission, and try to pull those launch dates closer to us rather than push them out.
Well, I was going to say, your dad, I know, is a big car guy. So when your dad was working on a Cadillac or something, he had like 2 years to get out the new model. And in some of these NASA missions, you're talking about, well, I know one of them in specific that we're going to talk about, you're talking 20, 30 years at times before it actually. So what are you, like the stuff you're actually working on, the ground level stuff on for now, what is the target implementation or mission on those?
Yeah, if you had something that started today, like a mission that is approved today, it's probably not going to fly. It kind of depends on the class of the mission,
of course,
but probably not going to fly till the end of this decade at the earliest, if not later. We're already working on stuff that's not going to fly till 2030 or so. So that's crazy. Yeah, you definitely have a longer roadmap, but you think about it's a lot of taxpayer money that's funding these things. We want to do the best we can, and space is hard. Everybody, it's kind of a phrase that's thrown around a lot, but it's challenging, and it's very obvious when something goes very wrong in space. So we really try to do the best we can to make sure that those missions are going to be successful.
Well, it's interesting. Of course, I 100% appreciate that. I think one of the questions I wanted to ask you tonight was going to be pertinent to the tragedies. We all know that the tragedies, there's been movies about it. Then there's just like, there's a middle school named Christy McAuliffe in my hometown. And what's interesting is not only are you someone that could speak on that, but you're actually a group that was formed as a result of that. So I imagine that you have a little, even more respect or more deep appreciation for how tragic that stuff was, maybe even than the average person at NASA might.
Yeah, absolutely. We talk about it a lot, like how those type of oversights and missed opportunities resulted in mission failure, in injury, loss of life, and that's a dangerous thing to skip out on. So my particular organization is called the NASA Safety Center, and that's underneath that Office of Safety and Mission Assurance. And we were stood up actually after the Columbia disaster. So in 2003, when Columbia crashed on its return to Earth, that was again due to some oversight in just how the shuttle was built and how it performed in flight during launch. And so we now are looking at every single mission like this and saying, what could possibly go wrong, and how can we test for it, and how can we build in this quality into our systems from the beginning so we don't run into those scenarios.
Yeah, I mean, it has to be helpful. And by the way, that's not to say that there wasn't a ton of safety factor built into those situations back then either. But with the fact that you have access to such amazing technology, software, and things like that for simulation has to be helpful too, right? But
of course,
what are people basing space simulation on when it's kind of like you can't really test it like you can on the mechanics of something here on Earth or something, right?
Right. So there is some amount of something that's lost when you're trying to do everything in a computer. But that being said, you can really simulate a lot of the all the like gravitational effects, the radiation effects, anything that's sort of going on in space. You can simulate that in a computer to really check to see if your mission is going to be successful going through those certain environments. What we do, especially at the Glenn Research Center, which is in Cleveland, Ohio, where I work, we do a lot of atmospheric environment testing. So we have very large like vacuum chambers where we can put real spacecraft hardware in there and test it as well to see how it will handle the vacuum of space in extreme cold environments.
Right.
So we do a lot of those physical tests as well.
That's crazy. It's so cool. So, I mean, so you've been there how long now?
Actually, yesterday was my 1-year anniversary at NASA.
Wow, that's why we should have definitely done it yesterday. I moved it out to today. It would have been so ideal. But okay, happy 1-year anniversary.
Thank you.
It's been a weird year to work at NASA, and that no one's
Definitely.
probably been going to work. What's going on with that? Are people going to the office?
We have opened up to, I think, 35% capacity on lab, but really that's a majority of those folks are the individuals that are doing those in-person tests where they need to be in the labs working with real hardware.
Yeah.
So since I'm doing software, one of the pros and cons, depending on how you look at it, is that everything can really be done remotely.
Right.
So my development team is 100% remote. Some of them I haven't even met yet, unfortunately, even though I've been here a year. But they're wonderful people to work with, and we've been able to connect virtually, I think. So I think in the future, maybe in 22, we'll be able to get back on site at least part-time. But we'll see what the future holds.
Well, yeah. So let's talk about you brought it in. It's a great segue. Let's talk about the future of NASA, because like I know in the outline you sent me, you had Artemis in there, which I understand is like the next our recommitment to going to the moon again. I don't really know anything about it, so maybe we could just start. What is Artemis?
Absolutely.
And I want the space nerd excited guy on this,
Right. So disclaimer here is I don't work directly on Artemis. A lot of my software can be used to support the efforts on Artemis, but that being said, Artemis is awesome. And Artemis is our generation's Apollo. So you talk to your parents and grandparents and they remember where they were in 1969 when Neil and Buzz touched down on the moon.
Mm-hmm.
That was a pivotal watershed moment in humankind and science and space and everything. We're going to have another one of those in a few years, and people don't really know that it's happening. If you say Artemis to a random person on the street, they're probably not going to know what you're talking about. If you say the Apollo program, they'll be like, oh yeah, wasn't Apollo 11 the moon one, right? They at least know something about it. Yep.
Right. Wasn't Tom Hanks involved?
Yeah,
in Apollo?
Exactly. Houston, we have a problem.
Right.
But yeah, so Artemis is actually scheduled. The first official Artemis mission is scheduled to launch in December as of now. We'll see how that date works out, but it's coming soon.
Like this December 21?
December of 21, yes.
Nice.
It is just an unmanned mission, but it'll be the first time since 1972, the last time we walked on the moon, that we're sending a human rated capsule around the moon.
Okay.
So we're using our new launch technology called the Space Launch System. So it's one of the largest rockets ever built, and it will be launching a capsule around the moon, uncrewed at this point, but it's really just proving that all this technology is working.
Yeah. So
and it's going to go extremely deep out on the backside of the moon. It's going to be really cool. And
so what are we hoping to, aside from proving that we can maybe send actual astronauts next time, like what is the overall mission? Is it just an aspiration going to the moon, or is there some actual scientific information that we're desperate to get from there?
Yeah, that's a good question. So obviously we've been there before. We've sent rovers there. We have a couple satellites around there right now, but what Artemis is trying to fulfill, and Artemis 2 will actually be a crewed mission in 2023. It won't be landing, but it'll be sending humans in orbit around the moon.
Basically the same thing that the first launch will do, but with people.
Correct.
Yeah.
And then the third Artemis, which will be in 2024, at least that's scheduled for right now, is where we will actually send people there with a lander, and they will land on the moon. And that'll just be sort of proving out that our technology here in the 2020s can do what we did in the 1960s, only on a much lower budget and much safer.
Yeah, right. With
but,
way better media too.
Right. And we'll have color cameras there, and people will be live streaming from the moon. It'll be really awesome. And I'm really excited for it. And I know everybody at NASA feels the same way. Cool. But we are trying to go there and stay. And I think that's the fundamental difference. Is the Apollo missions were just sort of like proving we could do it. We did it 6 times. There were 12 people that walked on the moon. They never stayed more than a few days, and then they came home. And then we were kind of done with it. We brought home a few hundred pounds of moon rocks back, did some science. It was fantastic, incredible for the 1960s. Right. If we just wanted to do that again, we could have done it a long time ago. But we're not in the business just to sort of go do what we've already done. NASA is really trying to push those frontiers, push boundaries, right. And then maybe commercial companies, which we can get into later, will follow in our footsteps. So we're looking to put people on the moon and stay there for a while, like actually build a lunar base at the southern pole of the moon, where we can harvest materials from the moon, like water, like helium, and actually convert that into usable products like rocket fuel and oxygen for breathing, and be able to set up like a base there.
Like a little city.
And we can then send additional astronauts there, and they can build out this city. And then we can do a lot of tests there that we couldn't do on Earth or in the International Space Station, for instance.
Right.
And then one other great thing that we're doing that everybody I talk to has no idea that this is happening. But in addition to us putting a base on the moon, we're actually putting a whole space station around the moon. So we're putting something called Gateway in 2023, I believe, where it will go out, and it's like an International Space Station, but it'll be orbiting the moon. So people will be hanging out orbiting around the moon instead of orbiting around Earth.
And these will be scientists or like guys like Elon Musk?
Initially, they will be astronauts, right?
Okay,
which will be, an astronaut is a very generic term these days. You don't have to be a fighter pilot or a test pilot to be an astronaut now. It's doctors, it's scientists, there's all kinds of people that go to space these days. But it will be NASA and their partners. People
more official.
Initially.
It'll be official, public business at that point. Still,
Someday, though, certainly Elon will find his way up to the Gateway space station.
I mean, is there something there that this is going to come across as kind of like a morbid question, but have we just screwed the planet up so far that we have to get the H out of here and like live somewhere else? Is that part of it?
I don't think that's what is on our minds every day about going to these other planets.
God, it's on my mind, Kevin. I think about
I understand.
It's like, I wish I didn't.
And I know that has sort of been a motivating factor for Elon for a long time. And I think that it is an important aspect of what NASA does is going out and exploring and finding those places where if things came to it, like we would be able to transition life to another planet. But we're not trying to do that in the near term. We're not building a colony on the moon so we can
start shuttling people there.
Right. Exactly.
Man. Okay. And that I was just going to say, my next question, if it would have gone differently, was, can you get me on the list? But
we'll see what we can do. You're young enough, Kirk. We'll get you up there.
All right. That's cool. Well, yeah. So what is going to be happening? So Gateway will have people on it all the time, and they'll be doing a set of experiments and reporting back and all of that. And then what are some other things kind of associated with the future missions?
Yeah, so I don't think Gateway will have people on it consistently, but at least from my understanding is there will be 4 people that fly out on a Artemis launch, and 2 of them will stay in the space station and 2 of them will land.
Nice.
And so we only have, as far as I know, again, planned through Artemis 4 at this point, but we do have, and we just recently awarded a number of contracts to have commercial companies help us get additional supplies and get people down there more consistently. So you'll have Artemis 5, 6, 7, and 8 potentially that will be bringing more and more people to the surface. And a lot of ultimately the goal beyond the moon is Mars, right? And everybody's like, all right, when we set foot on the moon 50 years ago, when are we going to Mars, right? That's the next big step. It's very hard. Mars is hard.
Space is hard. Mars is harder.
And it's a lot of it is to do with the distance. And there's at minimum a 14-minute delay between the Earth and Mars in terms of just sending signals. So anybody that goes to Mars is
on an island
on their own. Exactly.
Yeah.
And any of you that have seen The Martian kind of know how that happens. That, that's a great movie to sort of illustrate the challenges that you face when you go to Mars. So the moon is sort of a proving ground for us to go and try out some of these new technologies where we're actually walking around on another celestial body, but we're still close enough that if something bad happens, we're only about a 3 days ride back to Earth versus 6 to 9 months to get back from Mars.
Yeah, I mean, what are some of the huge? So you already mentioned a couple of the challenges of Mars, but there's a huge gravitational force there, right? Because it's large, right? Or
actually,
is that
Mars is smaller than the Earth?
So Mars is smaller. Okay, so
it's about 40% of the gravity of Earth.
What's wasn't that you and I have talked about this like over a drink one time or something, but
Sure.
in Interstellar, when like you get into a different gravitational like field or something, like time started becoming. This is not an official NASA position, by the way.
No, time dilation is a real thing in very high intensity gravity wells when you're getting
Explain it in layman's terms for everyone.
I'll do the best I can. So relativity says that the more acceleration you experience on your body, which gravity is, your experience of time is slower than someone who doesn't experience that gravity that's looking at you. So us from Earth's perspective, if you went near a black hole and then came back, it might have only been a few years for you, but maybe 25 years passed on Earth because just the time experience was different due to that gravity.
That's cool though.
But we don't really have to worry about that too much in the solar system because we don't have any gravity of that strength. The same thing happens when you accelerate close to the speed of light. So you could imagine future space travelers that are traveling to other space systems might experience some of that time dilation where their time passes more slowly than people that stay back on Earth.
Yeah, I remember reading a book when I was a little kid called like Singularity or something, and there was some like shed that they found, and when they went in there, there was time dilation happening. Interesting. Yeah. We got derailed. I have ADD sometimes.
No, that's fine. I mean, I love that relativity and time dilation is a really interesting topic. But yeah, it's not of all of the challenges on Mars. That's not.
Yeah, that's like infinitesimal. Yeah. Okay, so why is Mars the right candidate as like the first place to go then if there are so many challenges?
Well, I'd argue it's the second place that we're going because we have gone to the moon, but it is the first planet that we're trying to go to. And there's a lot of appeal to Mars, not just because humans inherently want to explore and see new things, but Mars has a very similar time period. Its rotation is 25 hours versus 24 hours on Earth. So you actually get sort of the day-night cycle that you would experience on the Earth.
Right.
It's got 40% gravity, so it's actually larger than the moon. The moon only has about 1/6 gravity of Earth. Mars has 40%. So the body should function a little bit better on Mars than it does on the moon. Walking around should be a little bit easier.
Yeah, throw on some ankle weights and just,
you're good. It feels like normal. You go play some basketball, just like 15-foot hoops.
Right.
There are a lot of challenges though to Mars. Like I mentioned, there's distance, of course, but there's also only about 1% the gravity, 1% the atmosphere of what we have on Earth. So the pressure on Earth is about 14.7 psi at sea level.
Mm-hmm.
It's about 1% of that on Mars. So you're essentially in a vacuum.
There's not a lot of oxygen floating around.
There's essentially
not a lot of anything
oxygen.
Floating around.
Yeah. There's essentially no oxygen. I think there's a little bit of like CO2, but Mars doesn't have a liquid core that we know of, and so it's not producing a magnetic field. And the Earth does that, and that's what protects us from solar radiation and cosmic radiation. Mars doesn't have that, so it's getting bombarded by the sun, bombarded by deep space with radiation. And so it's blasting what little atmosphere it has off into space. And so that is a huge challenge. Both of those things, the radiation and the lack of atmosphere, are a huge challenge to the first moon goer or Mars goers.
So the presumption would be that there will be some sort of like dome or something, obviously. So then we have to like transport oxygen there or something. Who knows? We'll be able to figure something out.
Yeah. Initially, I mean, we'll probably Ideally, we would send habitats before humans get there, because you wouldn't want a human just to go for 3 days and try to come back. It's not really feasible. They need to go for a while.
Yeah.
So we would send rovers and habitats to Mars uncrewed before humans went. So by the time they got there, they have all of their like life support systems on board, and they'd be able to survive for a while there.
So I'm not going to hold you to this, of course. Your bosses might at NASA, though. What are you talking about here, time wise? Like, what's what order of magnitude? 10 years or 100?
Like I said, it's hard, and the funding that we have is not anywhere near what we had during Apollo. And maybe once Artemis is more successful, the public will be more interested in funding it, and that will bring things closer.
Yeah,
I think 10 years ago we thought mid 2030s might be an opportunity for us to land on Mars. Now that we've sort of shifted gears a little bit and going back to the moon, hopefully it's not too much of a derailment. Hopefully it is a catalyst, right? And we've learned things there that make it easier to go to Mars.
And gets public support behind it, and maybe more money, private money behind it, and whatever it takes. Yeah.
Correct. But nevertheless, it's going to take some time to develop the technologies, the training, and then, like I said, just get those materials out to Mars before we even can go. And so, maybe 2040s.
Yeah. So, but not within our lifetime.
Within our lifetime, hopefully.
When things go well, that'll be, that's kind of crazy to think about. Does that make you feel a certain way?
Yes.
Like, cause when you're a kid, you grew up liking space.
I remember sitting with my friends, like in college, saying, I kind of want to devote my life to putting boots on Mars, not my boots, but somebody's boots. And I remember saying that like 15 years ago. And so I'm still committed to that. So that the thought of it happening, it does like fuel me every day. And I know it fuels a lot of people at NASA. And obviously the rover work that we've done is fantastic with Perseverance and Curiosity. We're learning a lot, but for all of the work that those rovers put in, humans could do things like that a lot faster. And it would just be so incredible to actually have like human intelligence on another planet to be able to do a lot of the research that these robots are doing now.
Yeah, it's so cool. You should catch us up a little bit. Actually, you just mentioned like we've learned a lot with rovers. So if you had to give an elevator pitch, you have 60 seconds. Here's what's happened since Columbia, I guess, which is probably like the last time, at least just the way the media's changed and stuff. You don't hear about cool stuff anymore. You hear about the nonsense. So what's happened in the last 20 years, 18 years?
Certainly, a lot of us remember New Horizons when it went by Pluto, right? And we got to see a lot of photos of Pluto for the first time. That was really, really cool. Now New Horizons has gone beyond Pluto and is out into the Kuiper Belt, where it's going to visit other asteroids beyond Pluto. So that should be really neat. In terms of Mars, we landed Opportunity in, Spirit and Opportunity landed in 2006. Perseverance just landed last year. Curiosity landed in 2012. So we've put quite a few rovers on Mars, and they're all driving around in different areas looking for signs of water, potentially signs of life. Perseverance in particular is really cool because it's actually taking samples, and it's just going to leave them on the planet on Mars, and then in 10 years we're going to go get them with another robot and take them back. So that's kind of cool.
Yeah, to see if it's a chain dynamic situation, or
to see if they're, we're trying to like drill into some of these rocks that we think were on a lake bed and see if they have some sort of salts, some sort of like baked in oxygen to prove that there was the building blocks for life. Yeah.
Oh man, I get this. It's inspiring stuff. This is why I always believe that there's always been a conversation in the public about the funding of NASA. I think there's a misconception about probably how much the actual budget is. So I'd like you to set us straight within the confines that you can. But to me, like, it's inspiring to continue to go past where your limits are. And I think, to me, that's why NASA was always more aspirationally was such an important organization, perhaps even more than any of the science that actually comes out of it. It's just like, how do you feel about that? What's your take on it?
Yeah, I think that's a great point. So I want to answer your first question about budget, and then we can talk about the purpose of NASA, or at least how I think about the purpose of NASA, and maybe not the official vision of NASA. But so in terms of budget, we're at somewhere around $25 billion, which is the most we've been funded in a long time. But you go back to, you take inflation into account,
and
you go back to back to the 1960s. I think 65 was the peak when we were really pouring everything into the Gemini and Apollo programs to get people to the moon. Obviously, the JFK speech early on in the 60s really motivated the country to try to land by the end of the decade.
And to beat the Russians, too.
And to beat the Russians, yes. So there was a lot of, so the Americans were sort of doing it alone. It was this national pride thing. And we were dumping close to like 4 to 5% of our federal budget at that time into NASA, which is a lot. I mean, it is still only 4 cents out of every dollar that you pay in your taxes was going to do this, but you know, that's a fair amount considering all the other
tangible.
Things that
you could actually see 4 pennies.
Right.
Yeah.
So nowadays, with our budget, which has steadily been increasing over the last, 6 or 8 years, slowly though, we're not spiking like we did in the 60s, but slowly, we're now at about 0.49% of the federal budget.
A tenth of its max. Yeah.
Yeah. So that's the challenge that we're faced with is trying to do these amazing, fantastic things and keep people safe and do it with a tenth of the budget that we did in the 60s.
Yeah. Well, you're in the software game. Like that's what makes it possible to some extent too. You know, like you have more AI these days.
Yeah, that is true. There's a lot of what we call digital transformation that is really trying to improve some of these processes that were slow and archaic and expensive and make them automated and fast. And using AI and machine learning is one of those ways.
And I hate to tell you folks listening at home, because in almost all the cases, those of you listening at home are humans. Humans are where the mistakes happen, honestly. So, like, not to say you can't make a bad software program that has a mistake in it as well, but like when people complain about self-driving cars and stuff, it's like that's safer than the drunk human that's behind the wheel most of the time, right? It's like, come on.
Absolutely.
Okay, and before we move on to the purpose of NASA, is there an influx of? You mentioned that like back in the day it was a space race, etc. Almost as if to imply that now it's a more international affair where we're kind of collaborating more. What's that look like?
Yeah, that's a great point. Is almost all major missions since the International Space Station, which started getting built in the late 90s, has been a collaborative effort. And part of that is because NASA just can't bear the cost of doing this alone on these large scale projects. But also, like, we really want to build those ties with other countries, and we work closely with the European Space Agency and the Canadians and the Japanese and their space agencies to not only get stuff funded, but actually, you know, they're designing components that are going on NASA spacecraft and that are being sent up. And they're in some cases they're even providing the launch capabilities. So we're putting NASA stuff on the European Space Agency's rocket, and they're taking it up for us. So there's a lot of those collaborations going on.
Yeah, it's like when people can move the pride out of the way, or organizations can move the pride out of the way, you can get a better product at the end of it all, right?
Absolutely. There's expertise all over the world. There's funding all over the world, and that's how we're getting stuff done.
That's cool. So what's the purpose of NASA to you?
Yeah, so there's a few things that I think NASA, so sometimes I see people, maybe don't ask me to my face because they'll think it's offensive, but you know, they'll say, why are we spending billions of dollars on NASA when we have all these problems here on Earth?
Oh, you said it here, not me. No, I'm joking. I disagree with that position. Anyway, go ahead.
That's a question that was given to me in quotes, right? I don't necessarily, so let me answer that question though. I think that there's about 4 different things that NASA provides the everyday taxpayer of the United States. So first and foremost, I think, well, not foremost, but first, exploration. And we've talked about this already. I think it's the human nature to go out and reach out beyond what they know and go find new places and put boots on the ground in new worlds, send spacecraft to deep space to see other planets, to see the beauty of the universe, the beauty of the solar system. If there's not profit in doing that, then no company is going to fund that, right? But we as a human race and as Americans have decided that we find value in that. And so that's one of the reasons why NASA does the things that it does, is it pushes that exploration.
Yes.
In addition to that, we're learning, right? We're sending up telescopes and we're understanding how the universe works. We're learning how to live on other planets, to go back to what we talked about. If we need to, in 100 years, move to Mars, NASA's going to be the ones that have helped pave the way for the understanding of what it takes to do that.
Right.
It's not necessarily a private company that's going to do that type of thing.
Yeah, not without exploiting the planet. Or, you know what I'm saying? It's like there's just more,
Yeah.
there's just more of a risk of exploitation when it's private money. It's
Yes, that's definitely true. The next thing is technology, and this is kind of what is often used as an argument here for this is NASA technologies aren't just used for NASA missions. They're also spun off. Like all of this technology is developed by taxpayer money, so therefore it's available to the taxpayers once it's, the IP's been understood and it gets rolled back out. And so there's a whole branch of NASA that is a technology transfer program that helps businesses understand what NASA has done and spin it into their own products. And we're here to support that. We spend millions of dollars trying to help businesses use the technology that NASA has developed.
through like a licensing type relationship, or it's like public.
It's free.
That's crazy. Yeah. Public domain. Yeah, that's cool.
Yeah, it's public domain because it's government funded. So things like let's see, the CMOS cameras in every single smartphone was originally developed at NASA. There's like infrared thermometers were developed at NASA. Like if you've ever slept on a Tempur-Pedic bed, that material
of course. I remember
made from NASA, right?
Time out, Kevin. You set me up for this one. I'm a big Mitch Hedberg fan. So listen, Mitch Hedberg has a joke where he said, "The Tempur-Pedic mattress is made of space material."
You know the Tempur-Pedic bed? The Tempur-Pedic bed is from NASA, and it's spongy. And if you call, they'll send you a free sample. So of course, I ordered 1,400 free samples. And then I got some glue. So basically, I fucked over NASA. Which makes me scared of their space program.
So
I do love Mitch Hedberg. That's fantastic. But yeah, that's great. I'm glad that you knew that.
The Tempur-Pedic. So that's kind of wild. So what are some other examples? I cut you off there.
Yeah. Well, another one is LASIK eye surgery was originally some of the technology came out of NASA, and there's lists and lists. And some people think stuff like, I don't know, ink pens or something came from NASA, or Velcro, and those are kind of myths that didn't really come from NASA. But there is a lot, and a lot of the technology and a lot of the software now is available for public consumption. We put a lot of our software up as open source to be used by other systems. And there are some of these things like stress test type of software that are used by private companies that was originally developed by NASA.
Yeah, that's not to mention all probably the military applications that have come out of it too, which are probably just lesser talked about, right? But the DoD is involved, and the Air Force and now the Space Force is involved in some of the things that NASA is doing. But the nice thing about that is that then people like me at NASA, I'm not worried about what they're doing. There's collaboration there, but we really can focus on the science,
expanding the science and the knowledge and human space travel. Yeah.
Does NASA do stuff outside of space, like outside of space exploration, or what else are they up to?
Yeah, so some of their budget is used to turn their telescopes back toward Earth, and in that.
Of course. So it's a surveillance program. Then you're saying
something like that, maybe surveilling the atmosphere more so than people. But
they're not watching my daily comings and goings.
I certainly don't think we have the resources for that.
You're not that special, Kirk.
There's probably other departments that you should be worried about than NASA.
Definitely.
But we do try to do support atmospheric research. We're supporting wildfire research, trying to understand where wildfires may go to and where they've been. And so there's a lot of things a lot of satellites that NASA is using to, try to improve the quality of life on Earth, and obviously concerned about climate change and working with NOAA and other organizations to really understand the impacts of what's going on in the atmosphere.
That's cool.
And how we can help prevent, problems down the road.
I thought you were going to say help prevent forest fires. I was thinking this is going full Smokey the Bear. Yeah. Dude, I mean, that's cool. That makes sense. So you already have the real estate and the cameras up there. You might as well flip them around once in a while, I suppose.
Yeah. I mean, there's a lot of satellites up there that are specific for that type of thing. And we're actually sending one, Landsat 9, I think, is going up in the next month or two. And so that will be doing a lot of that advanced research on atmosphere, motion of atmosphere throughout the planet, and try to understand how it's impacting the tides and all the other, sort of climate stuff.
This might sound kind of like elementary. It definitely will to you, but like, how are you actually transmitting information back here, like data? Is it in audible form, or like how? You obviously don't have a big cable going up to every satellite, right? So how is it actually getting back here?
Yeah, it's just radio waves. There's certain frequencies that NASA uses, and they encrypt their data, and it transmits back just kind of like how Wi-Fi does, just on a very large scale.
Yeah.
And there are, when things are in low Earth orbit, like the space station, or like these satellites that are looking back at Earth, it's fairly easy to just use a standard antenna to be able to receive them. When you talk about satellites that are out around Mars and beyond, you need much larger antennas to be able to hear them. So there's this concept of a deep space network that is a large array around the planet of these large antennas that are always kind of listening for our satellites out in deep space. But it's all radio frequencies that allow us to transmit information back and forth.
So essentially the wavelength of those giant telescopes is so huge that you just need a massive antenna. A receiver, basically.
Yeah, it's not just the wavelength. It's just the power. Like a little spacecraft out by Pluto doesn't have a lot of power to generate, so it's sending a very weak signal back. So we need a large collector
to amplify
be able to
amplify
it and understand it. Yep.
I see. That's cool. Well, yeah. So there you go. NASA's doing. They're not. For those of you that want to put this hypothetical on, like, don't you think we should fix the planet before we go out there and do? They're doing that too. Okay, so get off Kevin's back. He didn't come here to get grilled by you hypothetical people out there who may or may not be listening.
Trying to keep everybody happy.
That's man. They call him the mayor. Yeah. So, I think you have one more though.
I have one more.
You have a fourth tenet. Yeah.
And you touched to it. You kind of you touched on it. You stole my.
Oh, Mitch Hedberg. It's Mitch Hedberg. Sorry.
It's not Mitch, but what I think is the most important, and why I'm excited about NASA, is the inspiration aspect of NASA. Is that, like I said, everyone remembers where they were in 1969 when the Apollo 11 landed on the moon. And a lot of those young kids can cite that as, here's why I went into engineering, or here's why I went into X, Y, or Z, because of that moment. Right. And same when, Sally Ride first flew on the space shuttle, women now realized, hey, I can be an astronaut, or I can be an engineer. And I think that is what NASA is truly about at its core. It can inspire people, especially young people, to maybe be a little bit more than they thought they could be. And it's hard to put a dollar value on that. It's maybe the least tangible of all those items, but it's perhaps the most rewarding in terms of like the long-term benefits to society. And I'm one of those people. Is like, I went into computer science and I worked on all this stuff. I worked on trying to make airplanes safer and more efficient because of NASA. And that, I may not have done that had NASA not been a thing.
I feel bad for stealing your thunder, but honestly, I was getting the chills when you were telling me your way. So you did a good job. So
it was a team effort.
Yeah, I think. By the way, the team effort part of it is a big part of it too. Like seeing crazy human feats, no matter what it is, especially when it requires collaboration. And by the way, now it's public-private collaboration. It's international collaboration. That's inspiring too. More people need to be willing to step out of themselves and realize that you're not as smart as you and another person and you and 5 other people. And, so I think that's a lesson too.
I agree. Yeah. I think that was sort of like a 4B on my list it's
part of that.
That collaboration that we spoke to is inspiring as well. And then also just builds ties with those other countries in a way that maybe we wouldn't have had we not, shared a tin can up in space.
And I'm floating in my tin can. Planet Earth is blue, and there's nothing I can do.
Yeah, so before we get into a little bit more out there astrophysics kind of conversation, you mentioned in our pre-talk about the James Webb telescope, right? What is James? Who is James Webb? What's the telescope, and why is that exciting to you?
So James Webb was a prior administrator of NASA back in the 60s. And so we named this telescope after him. This telescope's been in development since the 90s, I think. Hubble went up in the mid 90s, and Hubble's done fantastic things and fantastic science. And everybody has seen those amazing images of deep space galaxies and supernova and things like that.
Yeah.
And what we've wanted to build ever since then is another space telescope that's even bigger and more powerful. And so we've done that, and it's very hard to do. Whenever you size up, it's just harder to get that much stuff into space without breaking it.
Of course. The
and
packaging
so,
and all that
yeah,
gets bigger.
exactly.
Yeah.
And the packaging of James Webb is nothing short of a miracle. I don't know how they did it, but it folds up. I mean, it's huge. Like the whole thing folds out to the size of a tennis court or something, but they can pack it all up inside of like a 9-foot fairing. I don't know exactly the dimensions, but it's incredible what they've been able to do, but it is much larger than Hubble. And I don't remember the exact ratio, but it's hoping to be something like 100 times more powerful than Hubble. And it's actually it's been in development for 25 years now or something, but it's being launched. I think the launch date is the 18th of December is the anticipated launch date.
Damn,
so
it's happening.
Everybody is like feeling the pressure a little bit right now because it's there's a lot of money, a lot of time. It was delayed multiple times, but it's finally ready to go. And if it gets to where it needs to get, it's actually going to be at we'll call it the second Lagrange point, which is essentially just a point out in space beyond the moon where it can just sit on its own and float there, and it can shield itself from the sun because it needs to be extremely cold to have perfect mirror surfaces and all of its sensors to work appropriately.
Right.
But it'll allow us to see further out into the universe, which also means further back in time because of how light works. So we'll be able to see like the furthest back, the earliest moments of the universe that we've ever been able to see. We also will be able to train it onto solar systems, exoplanet solar systems. And I do want to talk a little bit about that in a moment.
Yeah.
But we should be able to see planets orbiting other stars, like with decent level of resolution.
So other solar systems, presumably.
Other solar systems, yeah. No longer not talking about our sun and our planets, but other stars.
And then eventually we'll be able to get a telescope so big that we can actually see that multiverse version of Kevin or something.
Yeah.
Where you and I are having this conversation exactly somewhere else.
Yeah, right. Yeah, we'll see other people on other planets sort of like waving at us on the
looking
telescope.
back in their telescope.
Yeah. Exactly.
Wait, what? Holy smokes. Dude, that's exciting. That's super exciting. Well, I'm glad James Webb is getting his due because that dude knew how to fundraise, if nothing else.
Yes.
I mean, he had 5% of the national budget. That's insane.
He had a tough job, but they got it done back then. It's pretty remarkable. So we're trying to follow in their footsteps, and it is fun to be able to be in some meetings with people who are around during the Apollo time and listen to what their stories are about the challenges that they faced.
Yeah, dude, it's really cool. It's really cool. I imagine the workforce, because of the commitment to diversity and things like the workforce at NASA is probably a better representation of the population than like maybe you saw at GE Aviation. No offense to GE Aviation, but you know what I'm saying? You know, like I've been in the auto industry. It's heavily male dominated still. What's the mix down out there?
Yeah, I mean, the people I work with are extremely diverse, and my manager is a woman, and her manager is a woman, and
hell yeah.
I think that anybody can do great things at NASA. It doesn't really matter who you are or what your color of skin is. It's just about what your talents are, what your capabilities are, what your collaboration capabilities are. I think that's really important in NASA, is to be able to work with others and, get along with others. We all got check marks on our
yeah, you guys are all smart.
Back then.
Yeah, it's not a competition anymore. You're all smart. Now you got to figure out how to make it work.
Yeah,
what is the culture? What is kind of the culture there, like within the confines of what you can share?
Yeah, I think it's very collaborative. There's having worked in private industry for 15 years doing software development, it was a little bit more competitive, both amongst yourselves. You're fighting for those raises and promotions and things like that. But also the whole organization is built around turning a profit, and so you're competing against other
marketing
companies'
interests and just other interests altogether.
Yeah. Whereas, and that's been kind of a cultural shift for me for the last year, is like, there's not necessarily a bottom line, or we're not trying to be in the black so much as we're trying to be as efficient as possible as we can with the tax dollars that we get. So every day I'm thinking about how can I leverage the contractors that we're working with and the other civil servants to be as efficient as possible with the funding that we have. And so that type of unifying force has been really helpful in sort of getting us all rowing in the same direction. So I think it's a very positive culture. Some days are challenging, and some days you're so in the weeds that you're not really thinking about, hey, three chains down the way is somebody who's actually bolting on a piece of a spacecraft that's going up into space.
Going into space, yeah.
Yeah, you don't really think about that in your day to day when you're just like fighting with a bug or trying to deal with a production rollout that where a server crashes or something.
Right.
But ultimately, you can kind of take a step back and say, wow, I'm really working on cool stuff here that is contributing to something that I'm passionate about. And that really unifies, I think, the team a lot. People really appreciate that mindset.
Yeah. And I'm most like we talked about earlier, not in all cases, but a lot of people have had experience outside of that NASA, right?
Yes.
So like, it's probably a breath of fresh air for a lot of folks. Do you see what do you think? It obviously diversity matters and all of that, but like, what are some kind of commonalities that you see amongst all the people that you end up being around? Like, is everyone in the space? Are there people there that are just like not in the space?
I think so. There are certainly some people that are more interested in space than others. Not everybody has, for those of you watching on YouTube, like 10 different space paintings and artwork behind them all the time. Some people have giant NASA flags behind them. I think everybody believes in the mission and the goal of both what their job and their department's trying to do and then NASA as a whole.
Yeah.
But not everybody spent 15 years of their career just building a resume to try to get into NASA. Some people started as interns there because it was a good opportunity and they went to college nearby or had a professor that, knew somebody that went there and then just kind of stayed because working for the government, working for NASA is a really nice place to work. But definitely, probably more than your average company, people are passionate about what they work on.
Yeah, that's cool. It has to be that way it doesn't like NASA has a cool, like if you're an astronaut, everyone thinks that's so cool, but like, people don't really think about the day-to-day people that are just working there, know, and like, it's a hard, long timeline kind of project that if you don't believe in the end result, then you're going to pull your hair out. Right.
Yeah, definitely. It's not like working in the car industry where you get to drive in the car that you're building every year or anything like that. But, I've worked with astronauts at my time here and a lot of people have and gotten to meet them and when we didn't have COVID times and things like that. So you still get to sort of experience a little bit of that. And I'm looking forward to going and traveling to the other centers and working with people down at like the Kennedy Space Center and down at Houston and at JPL and at headquarters in DC. I'm already trying to plan those trips out because I do just want to experience the environment there, get feel the buzz, especially like, when a launch is approaching down at Kennedy in Florida. I think that is a special experience that not a lot of other companies really have that type of buzz and excitement, launching rockets. It's pretty cool.
No, yeah. I mean, they try to manufacture it like Tim Cook gets all the team together.
Yeah.
This is the new iPhone 13 with 7 models or whatever. And it's supposed to be like, watching something actually blast into a different solar system is going to be quite an experience.
Yes,
dude, it's cool. Well, I appreciate you sharing so much about NASA, and I'm sure it's going to be impossible not to continue to talk about NASA, but I want to get into a little bit here about exoplanets. What the hell is an exoplanet?
Sure.
And then I know this is kind of maybe cliche, but we got to talk about extraterrestrials at least a little bit, at least your own personal, no company line. I imagine that's not something that you're able to talk about, but what are exoplanets? And let's go from there.
Yeah. So, right. Like you said, this is no longer NASA business but now necessarily. Now NASA does
take your shirt off. Take your shirt off, Kevin. Yeah.
Cover that up. NASA does do a lot of research and fund a lot of research in these areas. And like I said, the James Webb is a tool that NASA is building that then scientists around the world and a lot of universities will be able to leverage. But so exoplanets really are planets that are just orbiting other stars. And we had always expected that they existed because we have 8 of them, right? Around the sun.
Yeah.
But there was no way to really know for sure with the technology we had up until about the mid to late 90s. We finally found our first one. And since then, we've found thousands. So there are literally thousands of planets that we know about that orbit stars around us, like nearby.
And that's all kind of in a relatively small area and
very
on the grand
small
scale
area
of the universe or whatever, right?
Yeah, just on the grand scale of the galaxy. I mean, I don't know the exact numbers, but there's something like between 100 and 400 billion stars just in the Milky Way. So, right, we're just bounding ourselves to our galaxy.
So is the Milky Way that thing like? Is the Milky Way like where you see that big spiral of like bright light with like
yes?
So that is all we're talking about, which is just a tiny little piece of sand in terms of the whole
The whole universe, right? So the Milky Way, you can actually see it if you're in the dark, dark environment at night, and you look up and you kind of see a splotch running across the sky. It's like a little bit lighter than the other parts of the sky. That is the Milky Way, and we're just happen to be in the middle of it. So you can kind of think of it as like a frisbee, and we're just in the middle. So when you look up, we're kind of seeing it spread over us in all directions.
Yeah. Okay.
But yeah, if you were able to take a spacecraft and go up by a couple 100,000 light years and look down on it, it would be that spiral disk that you have seen a lot of Hubble photos of other galaxies that are spiral galaxies that some of you are familiar with. But so if we're just bounding our search for extraterrestrial life to our galaxy, for instance, which has, like I said, between 100 and 400 billion stars, we've only looked at, gosh, I don't know, maybe like 10,000 stars. So like 0.01% of the total number of stars in the galaxy. And a majority of the ones that we've looked at have planets that we've been able to actually detect. So it kind of tells us that most stars will have at least one planet around them. So that's hundreds of billions of planets now that are in the galaxy.
Yeah.
Yeah.
So that's like the numbers are almost too that it's hard to even fathom what that
they're
means.
Hard to fathom. And so we can only look nearby just because the further it is, it's like trying to spot a fly next to it. Well, it's not even the time, it's just the distance. It's so far away that like a star and a planet orbiting it are just going to be so close together that you're not going to be able to discern one from the other.
Right.
So we have a few different techniques used to detect them, and I'll briefly touch on them. So probably the most common is when a planet actually moves in front of its star,
like eclipses it, kind of. Yeah,
exactly. It's an eclipse. The star's brightness dims briefly while that planet moves in front of it. And then it gets bright again as the planet traverses it and moves past. And we can detect that with pretty high accuracy, and we're able to then determine, how the periodicity, how often the planet's going, and roughly the size of it, and can calculate mass and things like that.
Can you determine relative size? Or you can actually determine like absolute size from those images?
You can determine absolute size from that because you know what percentage, you know how bright this and the size of the star, and if it dips by a certain percentage, then you can figure out the actual size of the planet that's moving in front of it.
Yeah, my God. When you're talking about distances that far, like just one little calculation error can really have major effects. It's like,
I'm sure it was challenging early on for the early scientists who were looking at these things and seeing like a dip of like 0.1% of a star's brightness, trying to figure out what the heck is this thing. And what really gets crazy is when you have 4 or 5 or 6 of them going at once. And so then they're all kind of making the star's light dip in random orders, trying to figure that out.
So does it seem like most of these other planets, exoplanets that we're finding are orbiting suns or stars that are similar to our sun?
That's an excellent question. That's a good question, Kirk. I'm proud of you. Most of them are not like our sun. Our sun is pretty normal, but a lot of the ones that we've been able to detect so far are usually smaller stars with the planets much closer to them. So a lot of the solar systems we've seen actually could fit inside of the orbit of Mercury, which is the nearest planet to the sun. But it's a smaller star. So, and that's just to do with how we're detecting them. But the closer the planet is to the sun, it's actually easier to see those it travel in front of it.
Well, yeah. It makes sense because it's at the end of the day, you're talking about light,
right?
So yeah. So then, would that mean that so would that mean if you're closer, even though it's a smaller star, the presumption could be that it's thermally impossible to live there? Or would that come down to the core, I guess the magnetic field around I guess I never considered that to be like a force field like you called it, but
yeah,
that's basically what it is. Yeah.
So that's these are other great questions you're asking. What constitutes habitability when we talk about a planet? And when we detect it, we can generally determine its orbit, and we can determine the temperature of the star based on its color and brightness. And then you can kind of do some math to figure out, is this planet far enough away from this size star to be in a habitable zone where water could exist? It wouldn't freeze and it wouldn't
evaporate.
Yeah. Right.
Okay.
So there's that Goldilocks zone, as some people call it, that the Earth obviously is because we have oceans. And so you can see other planets that potentially could be in their star's habitable zone. And then there's, of course, well, is that planet like Jupiter, there obviously can't be life on Jupiter that we know of because it's a giant ball of gas.
Right.
Or, something like it could be Venus, where it's just got so much atmosphere that nothing can live there because the pressure is so great and the temperatures are so high. So
Yeah.
it's hard to know, but you can kind of get an idea to say, all right, there's a chance that there's liquid water on this planet, and that's really exciting. We've only been able to determine that in the last 20 years, what planets might be habitable for life.
And I imagine that's a pretty small percentage of the 10,000 that we've studied.
No, not really, actually.
No.
That's the exciting part, is that there's a lot of systems out there that have planets in habitable zones based on their stars. Now, just being in the habitable zone doesn't mean it's necessarily habitable. There's other things like, if it's too close to that star, it's still getting cosmic radiation that probably would just bake anything on the planet, even though the temperature is not too high.
Yeah.
Or if the planet's not rotating, then one side gets baked and the other side freezes. There's all those type of things.
Yeah.
But we do see quite a few of them, and there are lists out there. I don't have it memorized, but of a lot of potentially rocky planets. We call them rocky because they're like the Earth. They're made of solid, not gas.
Right.
Rocky planets in a habitable zone that are, within an order of magnitude of the size of Earth. So like gravity is relatively similar to what Earth's is.
I don't want to nitpick here, but is it possible that you're being narrow-minded when you say that nothing could ever inhabit a ball of gas? Like, isn't there some type of being that could or something? Or?
Yeah, that's a great point. We only have one data point in terms of what is life and how could life exist.
Yeah.
And it's carbon based, and everywhere there's water, there's life on Earth, and places where there's no water, life is very challenged to survive. So we do think water is a key. And somewhere like the middle of Jupiter, where there's millions of pounds of pressure and extreme temperatures, and it's all methane and other toxic chemicals, we feel like life, it looks unlikely for life to form there.
And if it was, it would be a very different form of life than what we're looking for.
Yeah, it'd be hard for us to know what we were looking at.
Yeah, some amorphous little ball bearing thing that can put up that much power that might have huge intelligence, but
Right. Yeah. There's a whole industry of astrobiology trying to figure out what does life look like and what should we be looking for to try to detect it.
Yeah. I mean, is there some belief that God and ET can't coexist? I feel like that's constantly in conflict, but I don't understand why that's the case,
Yeah, and I don't know if I can speak to that too much. I certainly think that
it's a tough question, Kevin. I must say it's a tough question.
It is, and I think people who have a very strict belief in where they think life came from, if we do ever detect life, like definitive evidence of life existed in the past or currently exists, whether it be intelligent or not, they'll just have to sort of reevaluate what their understanding and their belief is of where we came from. So it is philosophical in some sense, but to me, it's just fascinating to think about what the opportunities are for life to be on other planets, and both within our solar system and in other solar systems.
Yeah, I mean, when you start thinking about the distance of all this stuff and the speed of light, I mean, it just takes so long. Like, we haven't even been alive long enough as humans to even made the trip to a neighboring exoplanet or something, right? At least, so it's like these things take so long that maybe it's happening. What are your thoughts on it? Personally, where do you think life is?
That's a great question, and it kind of goes to the Drake equation. If someone's listening and is like, "Oh my gosh, please bring up the Drake equation," I'm bringing it up now. So I
thought you were just I thought that was like a new song that Drake came out with. Or something.
Maybe, I don't know. Someone should tell him about it so he can write a song about it. And I won't go into the details of it because
give some details.
I'll give some details, but it's an equation that was just proposed, I think, back in the 50s, of trying to determine what is the likelihood that there is intelligent life out there, and the possibility that not only does it exist, but we could sort of detect that they exist.
That's built into the factor. That's factored in as well.
Yes. Yeah. So all of there's, I think, 9 factors in this equation, and each one just is a multiplier and then you eventually get the result of saying, we think that there should be at least 10 or 100 or 10,000 different civilizations that we should be able to listen to right now or hear from. And it sort of is based on, all right, how often are stars created, and then of those stars, how many of them have planets, and then of those stars, how many of those planets are habitable, like we were just talking about, and then of those planets, how many support like basic life, and then of those planets, how many evolve to have
Just
advanced life.
Funneling down,
Exactly, it's a funnel, and that's a great term for it. And then eventually you get to the point, well, all right, how many planets support intelligent life that is capable of broadcasting themselves? And then the last, kind of the scariest factor, is how long will a civilization last capable of broadcasting itself? And that's kind of the experiment that we're in right now.
Yeah.
How long before a civilization nukes itself out of existence, or decides, hey, we really don't want to be telling other people where we're at, so we're just going to turn our radio emitters off, and just listen instead, or something. So there's a lot of factors there, and you can get numbers ranging from like almost impossible, like Earth is the only one, to hundreds of thousands of civilizations that should be out there in the galaxy right now.
So is it an equation then, if it's all over the place like that? Or is
it's an equation, and it's a formula, but you have these numbers that you plug in, and some of them are very well known. Like, we really know how many planets on average orbit around a star, and we have a good idea of how many of those are in a habitable zone. But as you go further and further, the data points are fewer and fewer. We don't know.
It becomes more speculative, or right. Yeah. So where do you fall? You think I gather that you don't believe that we're like the only. Okay, maybe it's a better question in light of the final factor of the Drake equation. Are we the only civilization that's in existence right now within our realm of? I don't even know how to ask the question.
Sure,
it's too complex.
I understand what you're asking. Yeah, absolutely. So I do think that life outside of Earth has existed in the past. I kind of feel like it still does in the galaxy right now, but right now is such a relative term, because if they're on the opposite side of the galaxy from us, the galaxy is about 100,000 light years across, roughly. So if they sent a signal, we wouldn't get it for 100,000 years.
Yeah, exactly.
So it's like, who knows where our civilization will be like. So even if we exist at the same time, that's not all that helpful. You really need them to be, if we wanted to detect them,
overlap at the right distance.
Right. So they needed to exist 1,000 years ago, and then we would hear them, or they need to be closer, which is possible. And then we'd be able to hear them, in the not so distant past. But again, we've only been broadcasting ourselves for 80, 90 years, something like that. So that's a pretty narrow sliver of time in the scope of the universe, which is 13.8 billion years old.
Yeah.
And so it's very unlikely that it is a challenge to really think that in our galactic neighborhood, nearby stars, that there's any life there right now. But I'm not giving up hope. In fact, there's Alpha Proxima, which is a small star orbiting Alpha Centauri, which is the nearest star to us. It's only about 4 light years away. Does have a planet in the habitable zone, which is pretty cool. And there are already people that are trying to come up with ways to send a probe there, which is super exciting, with like solar sails, and just kind of use the power of the sun to propel it over to and you could get there within potentially a human lifetime, and actually have a spacecraft fly by another planet on a different solar system.
And presumably James Webb his telescope will be able to
see
that, that telescope will be able to see into that, or no?
Yeah, that's a great point. Another way we detect planets is actually just by observing them. So nearby ones that have huge planets, so we can observe them. I'm not sure if James Webb will be able to image it directly.
Yeah.
It certainly will be able to detect it, but I don't know if that planetary system around Alpha Proxima or Proxima Centauri is large enough for us to actually see or be able to discern, even with the James Webb. But other planetary systems, we definitely will be able to image directly.
Right. That's cool, dude. That's exciting.
Yeah.
What do you feel like what's the origin of the universe, and where are we, and what do you think the fate of the universe is? And when we say universe, are we talking about everything?
Yeah.
So that's like everything. Okay.
We're beyond just a galaxy now. The universe, at least there's different terms for what the universe means. So the observable universe is everything that we can see today. So it's sort of
which
like
is very tiny,
a sphere. Well, it's large. It's something like, the math kind of escapes me, but it's something like 60 billion light years across this sphere that we can see. And it's all to do with the expansion of the universe versus the speed of light coming towards us. But at some point, there's stuff outside of that range that light will never actually reach us.
It's like moving away from us faster than,
right.
Yeah, I see. Okay. So then does that mean we're getting torn apart then?
That's a great thought. So there is something called the Big Rip, and that is essentially the universe is expanding, and eventually it's going to just tear everything apart with it, because the space in between things is just growing with this concept of inflation, and that could be a fate of the universe.
Is that why my hairline's going backwards?
You can definitely blame it on dark energy and Einstein. It's probably it. Yeah.
Definitely. Okay. I feel better now. My eyes have been kind of further apart than they used to be too, I feel like.
Yeah, that's probably that negative pressure from dark energy doing it.
Okay. Well, then if we're not going to get torn from limb to limb, then what's the fate of the universe in your mind? Yeah,
I think the most accepted result is just called the Big Chill, or heat death, which is like a really unpleasant term, but it's sort of accurate, where gravity will still overwhelm it locally. It will outcompete the growth and inflation of the universe. So galaxies will still sort of stay together.
Yeah.
But over hundreds of billions of years, stars will no longer be able to perform fusion, and so everything will just kind of go dark, and eventually it'll all just, with gravitational radiation, it'll all just sort of clump together into these giant black holes, which we have, for instance, at the center of our galaxy, but black holes exist elsewhere. And then, so now all you really have matter is just all a bunch of black holes. And then there's black hole radiation that Stephen Hawking gave us that basically says eventually black holes will evaporate and just vanish into thin air, or into thin nothingness. And so then the universe will just sort of be empty at the end.
So have you read Isaac Asimov's I think it's like The Last Question, or
I don't think I have.
I'll send it. I'll put a link to it in the show notes, people. But I don't even want to get into it then. I'm going to cut out this whole part, but I'll send it to you. You should definitely check it out. You'll like it. It's cool. But he talked it's all about like trying to harvest energy from the sun, but then at the end there's no more energy. And then it kind of starts back up at the end though. So so I'll just go back to where you were.
Sure.
So, okay. So basically I'm picturing like a TV, an old tube style TV going dark, and all the black holes have collapsed, and now that stuff is just all gone, I guess. Who knows? Like, it's gone. But so does that imply, isn't there some also chance that would create like an additional Big Bang or something?
Yeah, there are some theories out there that the universe is sort of cyclical, and that our Big Bang came from a previous universe, like a big crunch, which is another fate of the universe, where gravity overpowers the expansion of the universe and everything kind of comes back into a giant singularity and could burst again into a new universe. Or there's sort of these other crazy that I don't fully understand and don't want to get into too detail, but these ideas that like the universe will exist for so long that eventually we'll run up into a wall where the only result is birthing a new universe out of it. And those are some ideas like Roger Penrose has, and they're very interesting, but
it's optimistic.
Yeah, well, right. Except that potentially our universe might die in the process, but that's kind of where potentially our universe could have come from, is a prior universe.
Look at that. Even in space, to everything, there's a season.
Yes, exactly. We're just in a nice human supported season right now.
I mean, the Big Chill is such a better name than Heat Death. It's like Big Chill kind of sounds like you might just be hanging out,
Right. Just grab a cocktail and, watch the stars go out.
Yeah, watch a Matthew McConaughey movie or something.
Yep.
Yeah, damn. Dude, this has been so fun. Let's talk about the multiverse. So I've only used the word multiverse in like I recently went to Hot Now. There's one Hot Now that remains in the world, in the known universe, the observable universe. And we were talking on that trip about how maybe in some other version of this place, McDonald's is the one that only has one left or something. So that's the only real context that I know. The term multiverse is kind of this like you know, like kind of like there's different instances of the same situation going on. What is it actually? Or, you know, how do you actually kind of put it together theoretically?
Yeah, so the multiverse in some sense says that there could be infinite number of universes and we're just living in one of them. And really potentially the parameters, like the fundamental parameters of the universe could be different for each universe. And ours just so happens to support life. Like the gravitational constant is very specific in our universe to allow stars to form. If it was higher or lower in other universes, then stars may never form, or they might blow up before life could exist. So it's kind of this thought that, well, maybe we're only special because we're here. It's something called the anthropic principle, in that we think our universe is special, but it's really just one of an infinite number of universes, but it just happens to be one that can support life. So we're observing it.
And more importantly, it happens to be the one that you, sir, not you personally, but the general you are actually living. So, and it's in human nature to think that you're special.
Exactly.
There's some element of that too, right? It's like,
yeah, well, it's probably an evolutionary thing to think that we're special and that we need to try to survive because we're important.
Yeah, that's true. If we were just another number, we'd be more reckless, perhaps. Yeah.
Yeah.
You're right.
There's another idea of the multiverse that I think you're also thinking about where, so this gets into quantum physics a little bit, but it's an idea that for every decision that happens, or for any time, there are two things that can happen. And this is sort of goes to like Schrodinger's cat type of thing, where a cat could be alive or dead, and you don't really know until you observe.
Oh, like the double slit, like the holographic universe vibe.
The double slit experiment, yeah. And there's this idea that, well, maybe both things happen, but it just sort of splits the universe, and now two instances of the universe exist: one that saw the cat alive, and one that saw the cat dead. And so now that this has happened so many times that there's an infinite number of sort of split parallel universes that are occurring, one in which Hot Now, never shut down, and other ones that they all did, and some that they took over the world and whatever. So those are all possible.
I have to believe in that other universe. If Hot Now really took off, they made a little bit higher quality food. I have to, but I guess maybe that doesn't fit the science. But I think about even within our own lives, Kevin, like when people tell, you've had someone lie about you before, or what, you know what I'm saying, whatever. And like, there are different realities that are around about you, your own life, based on what other people have said, based on what you've said. And so in some regard, I kind of like that as just a general, be honest and don't talk shit, because when you say that creates an entire narrative now that's forever true to at least some people.
Yeah. And nobody knows if any of these are true, and they're starting to try to do some experiments to detect these things, but who knows? And like you said, we should just really function or operate that we live in this one path of the universe. So we should be kind to one another and, do great things, because it's sort of the only one that we have. Yeah,
dude. The Carl Sagan's famous, like, pale blue dot, like that thing, I've heard people react to that as if it's like almost in a nihilistic way, like, oh, that's all we are. But I think it's the opposite. It's like, we're lucky. It's like, look at this crazy little situation. We got to take advantage of it. And you, sir, are definitely taking advantage of it, man. It's inspiring to see somebody follow a path that they're passionate about and make it happen, dude. It's so dope. I'm proud of you. I'm happy for you.
Thanks a lot.
Yeah, and we didn't even talk about the fact that you're a new dad. We didn't talk about the fact that you're a former professional football player. Semi-professional, whatever. You're like the Jackie Moon of the gridiron. But dude, it's been a super fun conversation. I hope you enjoyed it. Is there anything that we left out that you want to jump on?
No, I think this was great. And I do want to thank you for having me. And I want to congratulate you on doing such great things with this show. It's been entertaining. I try to catch every episode that I can, and you've done wonderful things, and you've gotten really good at it. So
thank you.
All of you listening at home, I hope you continue to listen to these podcasts, because they are really entertaining.
And honestly, while I've got you space folks that are interested in this kind of stuff, I should tell you the next interview that's coming out in a couple weeks from when you're hearing this is Ron Woods. He's a spacesuit designer back in the Apollo days. He probably was in the same room as James at one point, probably.
Likely.
And he's now does consultation on movies and does art, NASA themed art, which Kevin and I are going to try and hook up for Kevin's office. So anyway, we're putting this episode away. Check out the next interview with Ron Woods.
Yeah, I'm looking forward to that one.
Yeah, double. It's, you know what? F it. Let's make this a NASA podcast. forever.
I'm happy to come back.
Yeah, well, can you do it every Friday?
Yeah. All right,
Dude.
I'm okay. I could talk all day about NASA stuff.
You're
I
boss.
appreciate you giving me the platform.
Dude, honestly, we could pick some really specific thing sometime and do a deep dive on it. That might be fun.
I'd love to.
Yeah, maybe next time you're up here in in our neck of the woods, you can come stay with us. It'd be fun.
Yeah, I'll be up there soon. And all of you listening at home, put in the comments. Let us know if there's anything more you'd like to hear from me. I'm happy to come back and talk a little bit more in detail about.
So you know how we're only one tiny smidget, we're only one tiny little pale blue dot in the universe. That's if you take the universe, that's the outline that Kevin sent me. And what we talked about today is just that pale blue dot. Okay. So we have infinite more conversations. Kevin, I appreciate it.
Thanks a lot, Kirk.
Okay. What an educational and fun, exciting ride that was. Wow. Kevin, just to be in your orbit makes me feel smart. Orbit jokes. Okay. So I've been doing a lot of research. Despite being sick this week, I've been trying to learn some space-themed songs, and my search came up. There's a lot of David Bowie action. There's actually quite a few songs about space, about aliens. Unfortunately, I'm not very skilled as a singer. On top of that, I have this illness. And so I couldn't help but find a song that we all know and we all love. It's got space right in the title. It's one of our favorite space-themed movies. But I got to tell you, just an absolute doozy of a space song. There is absolutely zero reference to actual space in here, aside from the word space. And so now, if you'll indulge me, I've got a little one for you here.
Everybody get up, it's time to slam now. Got a real jam going down. Welcome to the Space Jam. Here's your chance, do your dance at the Space Jam. All right.
Space Jam. Peace out, everybody. That was funny, I think.